Julia. I'm from Brazil and I'm currently a student of PPCR 2020 Principles and Practice of Clinical Research. And finally guys, I made it. Let's do a review of Module 2 Basics of Statistics, and the bibliography I'm using is our course book, Critical Thinking in Clinical Research. Look guys, I'm a student, I'm not a TA, okay? So critical thinking while watching these videos. Okay guys, so in this video I'm gonna focus on parametric tests. And first of all, we need to know what are these tests. Those tests are statistical tests which have lots of assumptions in order to provide robust data at the end of the day, right? So these tests, they are more powerful than non-parametric tests, just exactly because these tests really have lots of assumptions we have to respect in order to have robust data and not produce some misleading result at the end of the trial, right? And what are these assumptions we have to respect to run parametric tests? Well, here we go. The outcome needs to be a continuous data, so it has to have order, and the spacing between each number is also meaningful and it can be measured, and it is interesting for the trial. We have to have a random sampling technique as well, equal variance, which I'm going to explain a bit, and normal distributions. So our data set needs to be normal distribution, needs to have the bell-shaped curve when we are talking about central tendency measures and dispersion of the data. Okay. Well, so talking a bit about variance. What is variance? Variance is the distance between an individual observation and the mean of the data set. So that is the distance, how spread is the data. Well, and how can we access variance? We can access it in three ways: by graphical representations such as box plot or scatter plot. We can also access it through standard deviation, so we access the largest standard deviation of the data set and the smallest standard deviation of the data set. If the largest deviation is bigger than 2 times the smallest standard deviation of the data set, then we have an unequal data distribution, right? So my two groups are not equally do not vary equally. And we can also access through statistical tests such as Levene's, but the most used one is the standard deviation. Although statistical tests have more power than standard deviation, but it is not like that much power. It can also give misleading results. Well, so the first type of parametric test we are going to talk about is the most used one, which is the t-test parametric test. Well, so what is a t-test? It compares two means. It compares the means of two groups. All right. Well, so here if we have like two groups that vary equally among groups, then we can apply a pooled t-test. And if the groups, for example, if the largest standard deviation is bigger than 2 times the smallest one, then we have an equal variance among groups. Then we have to apply Welch's t-test, okay?
That is just names, and that involves some math calculations that I'm not going to dive in because I would not be comfortable talking about math here. Okay.
So the types of t-tests besides Welch's. So we have the paired t-test, and this test compares one group, but in 2 different time points. So we have one independent variable measured 2 times. That is why paired t-test is also called repeated measures t-test, right? Well, if or it is related to two dependent variables. So we're talking about the same group, so as one variable alters, the other one will alter the same way, so they are really dependent. And the paired t-test has more power than the unpaired t-test because we are talking about one group. So we then we actually eliminate difference between groups, since we're just talking about one group, right? So we eliminate this kind of difference, and then increasing power, increasing how accurate I can affirm that the results I got with this test is true for this population, right? So then I can increase power. Differently from the Unpaired TTest, which analyzes independent variables, so I have one independent variable in each group, so analyzing two groups, two independent variables. Then I'll only analyze these variables in one time point, and since I have two different groups, I have to take into account differences between groups, right? So that is why Unpaired t-test has less power. And because we have two groups and these groups may differ between each other, then I need to adjust. To adjust for variances. Okay, then we go back here. The advantages of t-test. Well, it is a simple test, it is easy to understand, it is relatively easy to calculate, and it is the most common used. It is also robust for small violations of normal distribution assumption, right? However, the disadvantage is that it is robust for only small deviations of normal distribution. It can only be used with continuous data and in the outcome, and groups also need to be balanced, and the group sizes, mainly in the unpaired test, obviously needs to be equal, right?